So, hello everybody. This is going to be a short live update about what's happening today, tomorrow, and after tomorrow. So, yesterday I have started with this live course, which is in 4 parts, where you get to learn. You start with C. You get to learn basics of the C language. Then we go into RTOS, and then we learn about STM32, and then we make a circuit board for STM32. So it's a really nice, very short course. I'm trying to cram as much as possible into it. And really just sort of the result that you should get out of it is that you should understand how to actually make a very simple product for yourself, which you can get started with. And this course is currently ongoing. And if you watch this later, you can still probably join the course. You just have to go to swishembedded.com/start embedded. And there you will see the exact times and the dates for this course. So that's ongoing, and if you want to join right now, you can still join right now. I will go over the old material with you. I can actually send you some slides and you can have a look at them, and if you need a little bit more, I can go over the old material with you once again, because that just makes it easier for me to clarify the material and make it better. So you can still join today. Just go to swishembedded.com/start embedded. And also I'm looking for teachers. So if you are a teacher, if you are teaching in embedded systems, maybe you're currently going to university and you do teaching on the side, then contact me. Just send me an email to info@swishembedded.com, and we can get you on courses. Maybe you can teach something that's interesting. Maybe you can teach something that's a little bit outside of what I'm doing. So that would be really fun. The focus today is going to be on RTOS, and this is an interesting subject because even if you look at, for example, Rust programming language, there's a lot of libraries, and just like with Arduino, there's a lot of small libraries that allow you to interact with microcontrollers, so like the Cortex-M microcontroller. But it's the same theme for all of these systems. Like if you look at the Rust manual and you start digging deeper into real-time operating systems, concurrency, how to actually add concurrency to the language if you're running it on a different, like on a smaller system, without using operating system threads like you would do on a PC. It kind of gets a little bit weird, and people basically resort to run to completion concurrency, which is basically just having interrupt routines that can be nested, of course, but it's still kind of like run to completion. So everything has to run to completion before anything else on the same priority level or lower priority level can run. The biggest problem with the run to completion is that you cannot break the execution at a particular time, but you have to sort of complete the execution, and you can't do things like easily return from an interrupt into a different task if data is ready and if data needs to be processed. So it has its limitations, and it's basically like Windows 95 or Windows 3.11, where you had this run to completion. You had the main loop where you had basically just you would loop through the events that Windows was sending you into your window, and things like key presses. They were just messages, which were just integer numbers, and you would then have a big switch statement where you check for whatever event that has occurred, and then you would do something, and then you would return from that message from that Windows message handler, and wait for the next event to occur. So when it comes to concurrency with RTOS, we're going to talk about actual task level concurrency, where you can have a task and you can just break that task and load a context of a different task, go to the other task, do that task for a while, and then come back to the first task. So it's a much more flexible way of doing concurrency, and most importantly, it doesn't put constraints on your code. Like it doesn't constrain as much the code that you write, as long as you don't share data. When you share data, you do have a little bit of constraints, right? So you still have to manage concurrent access to shared resources. But if you don't worry about that part, and just look at the structure of the application, your application doesn't need to be inverted. It doesn't need to be transformed into a switch statement. It doesn't need to sort of have this inside out architecture. You can just write your application as normal, and you can have arbitrary level of function calls in your application, and then at any time, at any point, anywhere, the system might decide, okay, so now we need to do something that's higher priority, let's go do that for a while and then come back to your task. So that is basically what RTOS allows you to do. And it's a way of adding managed execution to your microcontroller application. It's something that manages how your program executes, but does so from outside of the program. So we're going to look at that today. Go to swedishembedded.com/startembedded and register for the course, and I'll see you on the course. By the way, also, if you register on the course, you will get an invite to the Q&A. Q&As are free, but I'm sending invites to, I add people to the invites several days before the Q&A, so you wouldn't get an invite to that Q&A if you register on the free account, unless you register for the course today. Then I will send you also an invite to the Q&A. So that's going to be 3 hours today. First it's a Q&A, then it is the presentation about RTOS, and then it is Q&A for RTOS specific stuff. So we'll actually look at examples, and I'll make sure that you can get started. You can get get running with RTOS. And then tomorrow we look at how we put this RTOS on STM32 and what that actually means in practice using an RTOS on STM32. And then the day after tomorrow, we look at how we create a small board for STM32 and then program it with our RTOS. So that's it for today. And thank you for watching. Subscribe to my channel, and I'll see you later.